Welcome to day 54 of the low-level design course. Today's session focuses on a crucial topic, writing test cases. Test cases are a fundamental aspect of ensuring that our designs and implementations are robust, reliable, and maintainable. In this session, we will dive into why testing is critical in low-level design, explore various types of tests, understand how to write effective and clear test cases, and also highlight common mistakes that developers make when writing tests. Whether you are building a small module or working on large, complex systems, writing effective tests is essential for software quality and long-term success. Let's begin. Testing is not just a step in the development process, it's an integral part of low-level design itself. So why is it so important? First and foremost, testing ensures software quality. Without tests, it's impossible to know whether your design is working as expected. Imagine implementing a new feature or refactoring an existing module without proper testing. Bugs might slip through, leading to a poor user experience or worse, simple system failure. Moreover, testing helps uncover hidden design flaws early in the development cycle. These flaws could be due to misaligned requirements or design decisions that work in theory but fail in practice. When tests are written alongside your design, you can identify these issues before they escalate. The ultimate goal of writing tests is to ensure that the software is correct, reliable, and maintainable. By rigorously testing your components, you ensure that future updates or changes won't break existing functionality. Testing also encourages better design choices, designs that are modular, loosely coupled, and easy to maintain. It's not just about catching bugs, it's about reinforcing good software architecture principles. In low-level design, you will encounter various types of tests, each serving a unique purpose. Let's take a look at some of the most common ones. Unit tests. These are the most granular level of testing. Unit tests focus on individual components, typically a class or a method. The goal is to test small, isolated pieces of functionality to ensure they work as expected. Unit tests should cover the basic, everyday scenarios but also explore edge cases where things might go wrong. Integration testing. While unit test checks individual components, integration tests verify how different components or modules interact. For example, if you have a service that depends on a database, integration tests will check if the service works correctly when connected to the real database. Contract tests. These tests validate the behavior of interfaces and APIs. They ensure that when you interact with external modules or services, the contract is being followed. Behavior driven test (BDD). BDD focuses on testing the expected behavior of the system from the user's perspective. Instead of testing code directly, BDD tests user stories and interactions, typically written in a more natural language. Negative tests. These tests explore invalid inputs and edge cases. Essentially, they check that your system can handle errors, incorrect data, or unexpected conditions gracefully. Negative testing is vital to ensure the robustness of your design. Let's now dive into unit testing, which is the foundation of writing test cases. The essence of unit testing is to test small, isolated units of functionality, typically methods or functions. The goal is to validate that each individual piece of your system works as expected in a variety of scenarios. When writing unit tests, it is crucial to cover both normal cases where everything goes as planned and failure scenarios. Failure scenarios include things like invalid inputs, exceptions, or boundary conditions. For example, if you have a method that processes user data, you want to test not only valid inputs but also empty data and malformed data to ensure your method can handle these gracefully. A key concept in unit testing is mocking. Mocking allows you to simulate external dependencies such as a database or an external service so you can isolate the behavior of the unit under test. This helps you avoid unnecessary complexity and ensures that your tests focus purely on the logic within the unit itself. Writing effective test cases is more important than just writing code that passes. It's about clarity, precision, and ensuring your tests remain maintainable as your system evolves. A widely accepted pattern for writing tests is the arrange, act, assert (AAA) pattern. Arrange. Set up all the necessary objects, variables, and states required for the test. Act. Call the method or function you want to test. Assert. Verify that the result matches your expectations, either by comparing it to a known value or checking side effects. In addition to this pattern, test cases should be self-explanatory. A good naming convention like should return true when input is valid makes it immediately clear what the test is checking. This clarity is especially useful as your test suite grows and as other developers work with your tests. Lastly, always ensure that your test cases focus on one behavior at a time. This makes your test easy to understand and maintain and allows for better debugging when something goes wrong. Mocking and dependency injection are two powerful techniques that improve the testability of your code. Dependency injection is a design pattern where dependencies are passed into a class rather than being created inside the class. This makes your class easier to test because you can inject mocked versions of the dependencies during test, which allows you to isolate the unit under test and avoid external side effects. Mocking, on the other hand, involves creating fake objects that simulate the behavior of real dependencies. For example, if your class depends on an external service like a payment gateway, you might mock that service in your test. This way, you avoid actual network calls and can focus on testing the logic of your class in isolation. Libraries like Mockito for Java or unittest.mock for Python are widely used for mocking. Let's walk through an example of writing unit tests for a booking service class. The booking service might contain methods like book ticket or cancel booking. We want to test different scenarios. Successful booking. We simulate a scenario where the booking process goes smoothly and the expected result is returned. Booking failure. What happens when there are no available seats? We want to ensure that the system handles such cases correctly. Payment error handling. If the payment fails, we want to verify that the system correctly handles the error and provides feedback to the user. In each case, we would mock the external services like a payment gateway or ticket availability service to ensure that our tests are isolated and don't rely on external systems. Test coverage refers to the percentage of your code that is covered by tests. It's a good metric to track, but it's important to understand that 100% coverage does not guarantee that your software is bug free. The key is to focus on critical paths and edge cases, the parts of your system that are most likely to fail or cause issues. There are three main types of coverage. Line coverage ensures each line of code has been executed. Branch coverage ensures each decision point in the code has been tested. Condition coverage ensures every logical condition has been evaluated both to true and false. Tools like jcoco for Java and coverage.py for Python can help you track this coverage. However, remember that test coverage is just one aspect of testing. Focus on writing meaningful tests that validate business logic, not just covering every line of code. Writing tests can be tricky and developers often make some common mistakes that can lead to fragile or ineffective tests. Let's go over a few. Over mocking. It's tempting to mock everything, but mocking too many dependencies can lead to tests that are tightly coupled to implementation details. Aim for realistic mocks, just enough to isolate the behavior under test. Testing implementation instead of behavior. Don't test specific implementation details like private methods. Instead, test the expected behavior of your class or module. This makes your tests more flexible and less prone to breaking when the implementation changes. Not updating tests after code changes. If you refactor your code but forget to update your test may no longer reflect the new functionality, leading to inaccurate results. Ignoring exceptions paths. It's easy to focus only on happy paths, but exception paths are equally important. Test how your system handles edge cases, invalid inputs, or unexpected failures. Now it's your turn for today's hands-on practice. You will write unit tests for two classes in your capstone project. Ensure that you cover both the positive and negative cases. For example, test for valid inputs as well as invalid inputs, edge cases and potential failures. Use mocking for any external dependencies like databases or services to keep your tests isolated. Once you have written your tests, share them for peer review. This is a great opportunity to refine your skills and receive valuable feedback. To wrap up today's session, here are the key takeaways. Testing is a vital part of good software design. It helps ensure your system works as expected and can be maintained over time. Write tests that are modular, isolated, and focused on behavior. Keep them clear and easy to understand. Mocking and dependency injection are essential tools for making your code testable. Test coverage is important, but the quality of your test is far more critical than the quality. Finally, continuous improvement. Testing is an ongoing process. As your system evolves, keep refining your tests to cover new scenarios and edge cases. I hope this session has given you valuable insights into writing effective test cases. Testing will not only make your designs more reliable but also help you become a better software engineer. Thank you for your attention.